Hello everyone and welcome back to Instrumentation Hub. So as you have seen on the thumbnail, today's video is about the thermocouple. As I mentioned in the last video, today we are going to talk about the thermocouple. What is the working principle of the thermocouple? What are the different types of thermocouples and what basis we define different types? Also, how you can identify the different types of thermocouples. Also, we will understand thermocouple with the real-time example or application so that you will get a better idea. Lastly, the highlighted features of the thermocouples. As you guys know that my last video was on the different types of temperature sensors. And in that video, I have already given some key insights about the thermocouple. But in today's video, we will see in detail so that your all doubts about the thermocouple will get clear. So let's get started. But before moving ahead, I would like to give you a reminder. If you are new to this channel, then subscribe Instrumentation Hub and join me in the amazing learning journey. Okay, so on the screen you can see the diagram of thermocouple. So as we know, a thermocouple is a sensor that measures temperature. It consists of two different types of metals which are joined together at the one end. When the junction of the two metals is heated or cooled, a voltage is created and that can be correlated with the temperature. Now let's understand the working principle of the thermocouple. Thermocouple basically works on the Seebeck effect. You might have heard about it, right? Let's understand what is this Seebeck effect and how it works. Seebeck effect is a phenomenon in which the temperature difference between two dissimilar electrical conductors. In the diagram you can see the wire type A and wire type B. It means these are the two different metal wires which are carrying the current, right? So the phenomenon of the Seebeck effect says the difference between two dissimilar metals, which is the temperature difference, which produces the voltage, and as per the Seebeck effect, that voltage difference is we are going to measure. So for Seebeck effect, we consider two junction. First one is the hot junction and second one is the cold junction. When the heat is applied to the one of the two conductors or semiconductors, the heated electrons flows towards the cooler conductor or cooler side of the semiconductor or that wire. And in the case where the wire of this wire is connected to the circuit, then the DC current, which is direct current, flows through the circuit. And on that basis, we measure the temperature. Diagram में आप देख सकते हो, we have two junctions. एक है hot junction and second है cold junction. So whenever we are applying heat to the hot junction, the current which is flowing from hot junction to the cold junction. हमें पता है कि कोई सा भी scenario हो, the heat is always transferred from hot junction to cold junction, right? Hot part to cold part. So same case यहाँ पे भी है. We are applying temperature, electrons moving from hot junction to cold junction and which are producing the voltage. So this principle which allows to flow the electric current from these wires, and if we connecting the multimeter, any circuit to these wires, then we can measure the temperature between, or we can say the voltage between these two wires. Understood? The voltage produced by the Seebeck effects are very small, usually only 5 microvolts per Kelvin. But in the case of the large temperature difference, there are some Seebeck effect devices which produces the millivolts that we can use. Okay. So if you have any doubt, please let me know in the comments. Now we will move forward. Okay, from one more diagram you can understand. See here also same scenario. When heat is applied to the one of the two conductors, that metal heats up. The heated electrons present in the metal flow towards the cooler metal. This happens because electron moves to where the energy, or we can say the heat, is lower, and probably we connect these two metals to the electric circuit where we measure the direct current or the voltage, and this is how we get the output. Got it? Okay, so now let's move to the next part. So on the basis of different types of metals, the thermocouples are divided. There are three different types of metals which are used to manufacture the thermocouples. Some are base metal, some noble metal, some refractory metals. So base metals are common inexpensive metals, so you can easily identify in the market, like nickel, iron and copper. And with these metals, the E, J, K, N and T type thermocouples are made. Comparatively, noble metals are expensive. These are precious, and that is why we called it as a noble metals. These metals includes platinum and rhodium. This type of thermocouples basically consist of the ceramic protection, so that the metal which are present in the thermocouple should not get affected by the environmental conditions and continue giving the exact and appropriate outputs. These thermocouples are R, S and B type thermocouples. Refractory metals are exotic metals, which includes the tungsten and rhenium. These type of thermocouples are basically difficult to manufacture. These type of thermocouples mainly used in extremely high temperature. These metals generally not used in the presence of the oxygen, because these are somewhere flammable exotic metals. So the next question is how you can identify the different types of thermocouples. So the J type thermocouple is consist of white and red wire, and which is used to measure the temperature ranges from minus 210 degree Celsius to 1200 degree Celsius. Next one is a T type. T type basically consists of two wires which are purple and red, and this type of sensors used to measure the temperature from 0 minus 270 degree Celsius to 1000 degree Celsius. Next is E type. E type temperature thermocouples which are consist of blue and red wire, and these type of sensors are used to measure temperature from 0 degree Celsius to 400 degree Celsius. Last base metal thermocouple is a K type, and it is having yellow and red wire, and it also used to measure the temperature from minus 270 degree Celsius to 1327 degree Celsius temperature. Next are the noble metal thermocouples which are R, S and B. So these thermocouples are used to measure the high temperature. So for R, the color code is black and red. It will have the black and red cable, and it is used to measure the temperature from minus 50 degree Celsius to 1768 degree Celsius. Next is the S type. S type thermocouples will also have the black and red cables, and it is also used to measure the temperature from minus 50 degree to 1768 degree Celsius. The next noble metal thermocouple is the B type, and B type will have the color code gray and red, and these are the temperature sensors which are used to measure temperature from 0 to 1700 degree Celsius temperature. The exotic type of thermocouples are C, and which will have the red, white and red type of cables, and it is used to measure the extremely high temperature which is ranges from 0 degree Celsius to 2320 degree Celsius. So take a time and look at the chart and remember numbers and the color codes. Okay, till now if you have any doubt, please let me know. Now we will see some key points of the thermocouple. Thermocouples are basically mounted in the flow where we are going to measure the temperature, or we can say these are mounted in line or in the process line. So for the mounting we use the thermowheels. The thermocouples are mounted in a field with the help of thermowheels. ये thermowheel क्या है that we are going to see in the next video. मैं डिटेल में एक वीडियो बनाऊंगी जिसमें थर्मोवेल के बारे में सारे डिटेल्स होंगे, डिफरेंट टाइप्स ऑफ थर्मोवेल्स एंड हाउ इट वर्क्स विद द थर्मोकपल्स एंड डिफरेंट टाइप्स ऑफ टेम्परेचर सेंसर्स. It is important. So as we know, the thermocouples are used to measure the high temperatures, and it is also having the low cost and fast response. As we discussed already, it is having the two dissimilar wires, right? It is consist of two dissimilar wires. So sometimes air may pick up the radiated noise in the case where it is not shielded. So it is important that temperature sensing wire should be shielded to give us the accuracy. As compared to other sensors, thermocouples are considered as a low accurate device. Okay, remember these key points. Now let's see the application. Let's consider we have a tank and which is located remotely from the control room. So in this case, we can do one thing. We can mount the thermocouple in the tank and we can take the output to the remote location, to the central control room. So in the diagram you can see one thermocouple is mounted in a tank and it is connected to the control room with the help of wires. Here they have used what type of thermocouple, can you tell me or can you guess? As we have discussed, it will have some color codes, right? Thermocouple always will have some color code according to the types. So here they have used yellow and red cable. It means it will be definitely the K type thermocouple, right? As we discussed. So understood? So ये था a simple example of the thermocouple, कि ये thermocouple कैसे field में mount होते हैं, how it will take readings from it and send it to the control room. Okay, अगर कुछ डाउट है तो प्लीज़ लेट मी नो, और यू कैन आस्क इन द कमेंट्स, और यू कैन रीच आउट टू मी on the different platforms like LinkedIn and Instagram. I'm giving the links in the description. So I hope you have understood what is the thermocouple, how it works, what are the different types and how you can identify the different types, also the application. Okay, तो अगर ये वीडियो आपको अच्छा लगा हो और यूज़फुल लगा हो तो आप अपने फ्रेंड्स के साथ शेयर करो ताकि वो भी कुछ नया सीख सके. अगर आपको कुछ डाउट है, यू कैन रीच आउट टू मी बाय क्लिकिंग ऑन द फॉलोइंग लिंक्स. सो सी यू ऑल इन द नेक्स्ट वीडियो and want to say thanks for watching. Stay connected with the Instrumentation Hub and subscribe for more amazing videos. See you all in the next video. Till then, tata, bye bye.